Hi Math 2 students! Today we're going to do more work with circles. So just as a refresher, the equation of a circle is x minus h squared plus y minus k squared equals your radius squared. And h comma k is your center. So keep that in mind as we go through this worksheet. So the first one, it says use the information provided to write the standard form equation of each circle. And I guess I didn't really specifically say this is standard form. There's another form, I believe it's called general form of a circle, and it's just another way to write the formula. However, standard form tends to be really convenient for graphing, so that's why we're starting out with that one. So they gave us the center and they gave us the area of the circle. Well, we're trying to write the equation, and in order to write the equation, we need the center and the radius. We don't have the radius here, but what we can do is we can use the equation of a circle to try and find the radius. Or I'm sorry, we could use the formula for finding area. So if you recall, area of a circle equals pi times radius squared. So what we can do is we're going to put this in for area. So we get 49 pi equals pi r squared. And then we can divide both sides by pi. And we get 49 equals r squared. Take the square root. And usually you have to do plus minus, but you can't have a negative radius. So in this case, we don't have to do plus minus. And we're going to get that our radius is 7. So now we have our center and we have our radius, and we can write our formula. So we've got x plus 1 squared plus y minus 7 squared, and then that needs to equal our radius squared, which is going to be 49. Now you'll notice, right, if you notice here, that's just our 49, right? Since our formula is just radius squared, you can just take whatever's attached to pi from the area. All right, so how about let's take a look at this one. I want you to tell me what the radius is of this circle. So there's two ways you could do this. Since we know that the area is pi r squared, we know that whatever is attached to pi is our radius squared. So we could do it that way and then just plug that into the equation, or we can actually solve for radius and then square it again. It's kind of extra work, but we can do that. So we get 225 pi equals pi r squared. Divide out the pi, and we get 225 equals radius squared. Then you would take the square root, and we get that our radius is 15. So then again, radius squared would be 225. So we can go ahead and put that into our formula. We would get x minus 2 squared plus y plus 2 squared, right? Because you have to flip the signs from your center. And then equals our radius squared, which is 225. All right, next one. Let's see. Let's go ahead and try one where they give us the circumference. All right, so if you recall, we've got circles here. Area is like what's on the inside, right? Circumference is kind of like the perimeter of a circle. We don't call it perimeter, but it's kind of like the perimeter, right? It's the length of the outside. So the formula for circumference is 2 pi r. So what we can do is we can solve for radius, and then we are going to have to square it. The area is a little bit easier because the formula is literally just r squared times pi. So whatever's attached to the pi is your radius squared, and you could stick that right in your formula, as you can see here. However, with circumference, you do got to do a little bit more work. So let's go ahead. We're going to plug this in for our circumference. We get 4 pi equals 2 pi r. So we're going to go ahead and try and solve for r. We're going to divide both sides by pi, and we get 4 equals 2r, because our pi's cancel. Divide by 2, and we get that our radius is 2. So our radius squared has to be 4. All right, so let's go ahead. We will plug that in. we get x minus 4 squared plus y plus 16 squared equals 4. Now, this one just so happens that it ended up being the same value because 2 squared and 2 times r is the same value, it's 4. But that's not always going to be the case for circumference. It will be for area, but not for circumference. All right, so let's go ahead and try this one. The circumference is 8 pi. So we're going to go ahead and try and solve for the radius. So we're going to say 8 pi equals 2 pi r. So I want you to go ahead and solve that and tell me, what does r equal? So we're going to go ahead and divide both sides by pi, and we get 8 equals 2r. We should get that r is 4. So our radius squared is 16. All right, so we're going to do x plus 2 squared plus y minus 5 squared equals 16. So to kind of summarize, it depends on whether you're given the area or the circumference. If you're given the area, you need to use the area formula. If you're given the circumference, you need to use the circumference formula to solve for your radius. All right, so let's keep rocking and rolling here. So now, this is a little bit trickier. They gave us the center and a point on the circle, and we have to come up with the equation. So let's think about this. If we have the center of the circle, and they give us a point on the circle, the distance between these 2 points is your radius. So in order to find the radius, what you have to do is find the distance between these 2 points. So you're going to use distance formula. All right, and that is x minus, oh, no, it's not. I was starting the equation of a circle. You're going to do x2 minus x1 squared plus y2 minus y1 squared. All right, and you can go ahead and plug these in. So it doesn't matter which one you label x1 and y1 or x2, y2. We'll just do this one is x1, this one is y1, x2, y2. All right, we'll go ahead and plug that into our formula. So we've got the square root of 7 minus 7 squared plus negative 18 minus negative 17 squared, and we have to take the square root of that. So we end up with 0 plus negative 1 squared, which is just going to give us 1. So we get square root of 1, which gives us 1, which is our radius, right? Because distance equals radius here. So we can go ahead and come up with our equation now. It's just going to be x minus 7 squared plus y plus 17 squared equals your radius squared. 1 squared is 1. We get 1. We'll go ahead and try one more of those. So we've got our center and a point on the circle. So we're going to go ahead and find the distance between these 2 points. We'll label this x1, y1, x2, y2. So you're going to do 18 minus 16 squared plus negative, hold on, I did them out of order. Sorry, x1s, they don't have to come first, actually. I just had like slope in my head. So we'll do negative 6 minus negative 4 squared, and then 18 minus 16 squared. All right, and then we end up with, let's see, negative 6 plus 4 is negative 2. And then we get 2 squared, which is going to give us 4 plus 4. So we get root 8, which is our radius. So our radius squared is just going to give us 8. So we end up with x plus 4 squared plus y minus 16 squared equals 8. Now, one thing I want to point out, make sure that you put your center as your points. Do not use the point on the circle, because the equation, with the equation, you have to put it in, right, h and k are the center, not a point on the circle. So you have to make sure that you are using your center point here, not your point on the circle. All right, you guys are doing great. I know I'm throwing a lot at you, but you guys are killing it. All right, so let's go ahead and try arc length here. So arc length is related to circumference. So let's talk about the circumference formula. We know that that's 2 times pi times the radius, right? So what you can do here is when you are trying to find arc length, you're just looking for a portion of the circumference, all right? So what that means is that you're only going to do, you're going to essentially calculate the circumference and then only take part of it. So what you do is you have to figure out how much of the circumference this takes up. Well, the entire circle is 360, right? So for arc length, you're going to do your degree or theta over 360 times 2 times pi times your radius. So we get 270 over 360 times 2 times pi times your radius. Now, we're going to try and leave this in terms of pi. So I'm going to show you how to do that. To leave it in terms of pi, what you're going to do is you're going to multiply everything that's not pi. Ooh, I didn't put in the radius. How silly of me. The radius here is 2. All right, so we're going to do 270 divided by 360 times 2 times 2. All right, and we get 3. So we're going to do 3 pi. Again, I multiplied 270 divided by 360 times 2 and 2, and then just slap the pi on there. And the units here are just going to be, this one is feet. All right, awesome. Let's go ahead and try another one here. So first off, tell me what the radius is. What is my radius? So my radius here is going to be 13. All right, so we're going to plug it into our arc length formula, which is 135 over 360 times 2 times pi times our radius, which is 13. So we're supposed to go ahead and plug these into our calculator. Again, you're only going to plug in the things that aren't pi, because we're just going to slap pi on, because we're going to leave it in terms of pi. It's really important that you know how to do that. That is all over standardized tests. And the reason we do this is because it gives you an exact answer. Let's see, we could do, what I did is it gave me a decimal. Let's see, do they want you to put it in fraction form or do they want you to leave it in decimal form? Let's find out. It looks like they want you to put it into fraction form. So when you're leaving it in terms of pi, what you're going to do is you get your value and then you put it into fraction form and then you slap the pi on it. So you get 39 over 4 times pi. All right. Okie dokie. And then again, this is going to be feet because that's our unit there. All right. So let's go ahead. We got our last one here. You guys are doing great. We have to find the area of each sector. So of course, if we're trying to do area, we're going to have to use area formula. And basically, again, you're only trying to find a portion of the circle. So area of a sector is going to be theta over 360 times pi times radius squared. All right, so our radius here is 14. And our theta is 135. So we're going to do 135 over 360 times pi times our radius squared. And again, you're going to plug everything in that is not pi. So we're going to do 135 divided by 360 times, whoops, delete, times 14 squared. So then we get 73.5, and again, we don't want to leave it in decimal form. We want to get a nice fraction, so we get 147, oops, 147 over 2 pi, and then this is going to be inches squared. Area is always squared. Awesome. All right, let's do one more example of this. So let's go ahead, see if you could find the area of this guy. Use the formula theta over 360 times pi times your radius squared. So when I do this, I get 225 over 360 times pi times 8 squared. Plug these guys in. So I'm going to do 225 divided by 360. Ooh, I threw another 0 in there. Times 8 squared. And I get 40. So it's just 40. Oops. 40 pi inches squared. Awesome job.